Friend, guess who's back? Your inventor friend, guess who's back? Anyway, I'm trying to wobble my boobies. Wow, man boobs! Look at those sexy man boobies. Oh, oh. And the big belly, the big bear belly. You'll never get rid of me, Oliver. Anyway, all that manly chubbiness aside, chubby manliness. There's a new invention for you right there. Okay, so this one's a big one. This one broke my head doing it, but I did it in the end. This one's gonna be a long video, so get a cup of tea, settle in, pause, rewind if you don't understand what's going on, and just enjoy. It's a tour de force. It's a tour of me wanting to make the world a better place, and you admiring how great I am. No, I'm just kidding. It's I got lucky. I got seriously fucking lucky with this. Basically, halfway through, I had the formula for the ratio in the engine, and I just plugged it into a simplification engine on GeoGebra or one of those geo things, and it just spit out a really simple formula. And that's why I got lucky. Now I know how to simplify the formula myself, but I haven't actually simplified it. But I could go over it and simplify it. I've done trigonomic simplification before in the past. It's not a complicated thing. It's kind of it's putting the inverse of a function into a function to get the angle, and then using that angle to spit out the other line on a triangle. So it's all that's all you really need to do to simplify it yourself. Okay, so the first thing I'm going to do is I'm going to give you the spit out formula. I'm not going to do the formula. I have it somewhere on my computer, but the formula that I managed to get it to spit out from putting my formula in, which was this formula, or cos. Now I'm not sure if it's angle or x, but I'm just going to put x for the moment, or cos x plus 1. So that's the formula for the infinite gear linkage mechanism. So that's one of the parts, and I'm going to be doing a lot of this in parts. So that's the first part of this mechanism. Okay, the second part is the straight line mechanism. Now, people have already invented straight line mechanisms. They're very handy. I'll show you the one I invented. Okay, so my straight line mechanism is made up of several parts. First of all, it's made up of a parallel bar machine. The little round bits are the linkages in the thing. And the double lines mean they're the same length. The double lines crossing through them means they're the same length. And the single line crossing through them means they're the same length. Okay, so this thing is the what I call the parallel mechanism, or the straight line ensuring mechanism. So Rasputin, lover of the Russian queen. Okay, so that's the first one. So what happens here is this here, if you put anything on there, they'll always be parallel, and they'll always be in a straight line to each other. They'll always be parallel to each other. So that's the first part of that mechanism. This mechanism is going to take a bit, so I'm going to change color when I'm doing the next mechanism. So from that, you put on, this is the straight line mechanism now. You put on 2 wheels. Okay, so Rasputin. Okay, let me think. Okay. So okay, so this is my straight line mechanism now. See these three wheels on there, right? They have they're what's it called? They rotate at the same speed. So they have two wheels, one next to the other. That's why it's kind of outside and inside and outside and inside, and they can rotate at the same speed. Um, so they how is best to put this? Yeah, they can rotate at the same speed as each other. So that means that they can. What happens then is you create a scissors mechanism. So a scissors mechanism. And the what's it called? The wheels. It's going to be hard to explain this. So that's a scissors mechanism. See that there? It's a scissors mechanism. And what happens is you have a scissors mechanism from this bottom one. Let me see if I remember this right. So you have a scissors mechanism from this bottom one up to that. But the problem is it can tilt left and right. So you also have to have a scissors mechanism between that. So all those scissors mechanisms expand and contract at the same speed. And what that does is it means that that follows a circle like that. I'll show you. It follows those two circles follow a circle coming in like that and going out like that, following the circle. And that means that one in the center will travel in a straight line. The only problem is that at the 45-degree mark, the angles line up. So you put another mechanism below it that's slightly out of phase. So that's my straight line mechanism. It's quite simple, but from here on out, I'm going to represent it like this. So you can kind of create a piston that does the exact same thing as a straight line mechanism. And that's how I'm going to represent the straight line mechanism in the rest of these drawings. Okay, so that's the next part, the straight line mechanism. Okay, so the next thing we're going to do is we're going to create I'll create it with red. This one is what we call a rotation inverter. And a rotation inverter is very, very simple. So you have your so rotation inverter. What a rotation inverter does is it basically means that whatever's spinning on the left will spin exactly opposite on the other side of the spinning. So that's the rotation inverter. Now the next thing what you can do with that rotation inverter, I'll write this bit in green, is you can create a linkage mechanism differential. So instead of using gears to do a car's differential, you can use linkage mechanisms to do differentiation. So basically how that works is like this. I'm going to do the second thing in black, so the second wheel in black. So the second wheel in black, and then so I'm going to use I think I have another one, purple, for the outside mechanism. So the outside mechanism is the rotation inverter. So what I'm going to use for the symbol for the rotation inverter is just going to be thanks. So the rotation inverter. So that's going to be that symbol there, that purple symbol there is going to be the rotation inverter. So you have two wheels and you have you have around it a cog or a thing that's turning, and then we're going to put the rotation inverter symbol. It's kind of different than this one, the symbol is, but so what happens is in this is the differential. So the green cog and the black cog are beside each other, or the green disc and the black disc are beside each other. The purple thing is another disc that sits outside of them, and it creates an relation. What's it called? Rotation inversion relationship between the black and the green. So when you spin the purple to the left, both will spin to the left. But if you put more resistance on one side, the green will start to spin faster because of the rotation inversion. So that's a rotation inversion linkage mechanism. Okay, that can be very handy for other things too. It's going to come in very handy towards the end of the thing. There's two. Now there's the third thing is what I call a variable gear spinner. So I'm going to give this a nice, I'll give it a nice pink. We'll see. Pink might work. Oh, we'll do it red. I think we might have already done red, but we'll do red again. Okay, so just give me a few seconds. Red, it's, so we have a bar, okay? So that's just a bar that can rotate around a spot, right? That's just a bar that can rotate around a spot. I'll put a wheel in the middle to represent it, kind of thing. So that's a bar that can rotate around the spot. Now, beside it is another disc. I'll put that in black. Where's the black? That disc. Now, that disc can be like that, right? I'll draw another one, but what I mean is I'll draw another one that's wrong. So I apologize, I got that wrong. So there's my bin. It's over there. Score. I actually just clipped the edge, didn't go in. But okay, so let's start again. So you have that wheel with the bar sticking up on it like that. So wheel with a bar sticking up on it like a pedal. And then offset from that, we'll put the centers as dots. So we'll put blue dots as the centers. So there's the blue dot in that one. Okay. And then you have another wheel which is off center from it like that. And it also has a bar. This thing doesn't have a bar connected to it. What it has is a linkage mechanism connecting it center to the what you call it, the bar. So if you have a linkage mechanism, and I'll put another blue center. a bit of red. Okay, so you have two offset wheels. The blue, this it's kind of blacky, but see the dot and that dot are the centers. One is a fixed length, and the other is a linkage mechanism or a straight line mechanism connecting the two together. And that's called the variable spinner. As they spin, the actual speed difference between them will actually change as they spin. And that's where that formula I started at the start with comes from, is that ratio is, where is it? I can just write out the ratio again, I know it already. From the formula I put together, it's or cost plus 1. So the ratio is or cost plus 1. So now we need to stick it all together. So there's, to begin with, there's two ways to sort of do this. So to modify that, the distance, so or is actually the distance. So or is the distance between these 2 points, right? So if I do that and so or is the distance between those 2 points. So the formula, or cos plus 1 is, or cos plus 1 is the speed ratio between the two. Now there's another thing you can modify it there. So there's two ways of doing this. I'm going to do this the easy way, the first way, okay? So if you put a scissors mechanism in phase with it, so scissors mechanism, you can use reverse gears so it doesn't get stuck at the pinnacles of the actual as it's going up and down. So if you have this wheel here spinning, it'll change the length of it. So it'll actually change its length as that spins. It'll go back and forth, back and forth. If you stick that in there, you get depending on the length of it, and that's how you change the gearing. You get or cost squared plus 1. So that's basically gives you an infinite. It gives you or cost plus 1. Now what you do then is you get you make a second one and you put it 90 degrees out of phase, and that makes or sine squared plus 1. Then you shove it into the two differentials. You shove it into the differential, and the or becomes the ratio of the gearing. So whatever or is the length of that mechanism there, that's the gearing. That's the actual linear relation, or that's the gear ratio. So it can be between 0 and infinity. How you get infinity is you put it near or close to 0. You just put it at 0 and it becomes infinity and nothing moves. But if you want to become really, really, really big numbers, you just make it really, really small and then reverse which way the rotation is going from one mechanism to the other. The other way to do it is if you want if you want the distance between those two to actually be the ratio, so that just the or there to be the ratio, you send it through several of the differential machines, and you start removing by adding another by adding the original gear to it. You can remove the 1 from the or cost plus 1, so you just get costs, and then you can then multiply the you can then send it through another one of those, and it'll multiply and become cost by cost, and then you'll have cost by cost or cost by cost, and then link it to an or sine by sine, and you'll have link it to an or sine by sine, and you'll have just whatever or is as the ratio between the gears. Now there's plenty of uses for these. There's an invention I'd like to add to this called a phobic bearing. So as water and oil don't mix, And if we can do that with solids and polish them hyper smooth, we can create, and you can maybe get it so it wears smoother and smoother over time. We can get super accurate bearings and super smooth bearings that don't ever need replacement. So that would be one of the main things you could put into this mechanism. You could also put it into cars and create completely non-slip differentials just by varying the speed of the wheels. And then you could also create super accurate dial gauges, because it wouldn't have to rely on point contact gears, because it would rely on area contact gears. So that's the infinite gearing mechanism. How it works, it works through linkage mechanisms. There'll probably be, after this, there'll probably be a glut of people using linkage mechanisms to create infinite gears in other ways, but that's the way I did it. So hopefully you'll understand it. You'll need a bit of maths, like a bit of trig, to understand it, and a bit of you'll need a bit of working out. Like, it's not going to be immediately clear what I've described there. So take your time and look through the video and see, can you work it out yourself. I may have made a few mistakes in the calculations. I presume those calculations are right. So if you double check it, put it in the put a comment below, and I'll put it in the comment section of the video, and say that actually this is the formula that gives the linkage mechanism working. But the differentials will be able to add and multiply. If you put the two things into the differential, and then the third is the output, that's how it adds the two and then divides by their average, and that's how the differential works in that way. If you put the differential or the mechanism that multiplied and created the difference, and then you put it through the mechanism again, that's how you multiply. So that's everything to do with that mechanism. And that's really my magnum opus of inventing. That was kind of like my second last great invention. I hope you enjoyed it. It was a work of love and a work of labor. And go out there and start inventing, guys, because it's an infinite field. And the reason it's infinite is because it's creative. You create your inventions. They're not something that just pre-exists and you discover. You put you into your inventions, and that's how they work. Good luck and sayonara.